Class, I am going to discuss about the analytical solution of the problems given in mock test 2. The test held on today, 20th May 2022, and the topic of the exam was modern physics. Total number of questions allotted 30 and time given to answer the questions was 30 minutes. Let us take the first question. A C amplifier circuit built using an NPN transistor is shown in the adjacent figure. Here is a circuit diagram of the transistor. Its DC current gain is 250. DC current gain is 250 and RC is 1 kilo ohm. This RC is 1 kilo ohm. VCC is 10 volt. VCC given is 10 volt. What is the minimum base current for VCE to reach saturation? All you know that current gain, the transistor is operating in the C mode. So the current gain is given by IC by IB. DC current gain equals to IC by IB equals to 250. It is given. Now, what is IC here? VCC is 10 volt, RC is 1 kilo ohm. So IC equals to VCC by RC. VCC by RC means 10 by 1, that is 10 milliampere. Because the resistance is given in kilo ohm, so the current IC is in milliampere. Now, what to do? We have to calculate the minimum base current. Minimum base current. Now beta equals to IC by IB equals to 250, where IC equals to 10 milliampere. Hence IB equals to IC by 250. IC is 10 milliampere, so this is 10 by 250 milliampere. IB equals to 1 by 25 milliampere. But all the options are given in microampere unit. So convert this current to microampere unit. You need to multiply 1/25 by 1000 to get the current in microampere unit, and that is 40 microampere. Hence our correct option is A. So the answer to the question number 1 is A. Now switch over to the next question, that is the question number 2. In the question number 2, we see that the radiation corresponding to 3-2 transition of hydrogen atom falls on a metal surface to produce photoelectrons. These electrons are made to enter in a magnetic field 3 into 10 to the power minus 4 Tesla. If the radius of the radius of the largest circular path followed by these electrons is 10 millimeter, the work function of the metal is close to. So, there are two aspects of the problem. Number one, it is a hydrogen atom problem, and the radiation, thereby radiation emitted from the atom emits photoelectrons. Next, the second portion of the problem is from photoelectric effect, and the photoelectron is also subject to magnetic field, and it is circulating in a circular path of radius 10 millimeter. So we have to start from the end. The radius of the orbit r equals to mv by be. But when we are concerning about the energy of the photoelectric effect, then we have to convert this radius expression to the energy expression. R equals to mv by b. All we know that the relation between momentum mv equals to p equals to root over 2me. So mv should be replaced by root over 2me by b. So E equals to what? From this very expression 1, we get b square e square r square by twice m. B square e square r square by twice m. This is the energy which revolves the electron, in the magnetic field, and the energy, that is the kinetic energy of the electron, we get from this expression the kinetic energy of the expression. Here B is 3 into 10 to the power minus 4 Tesla. So B square is 9 into 10 to the power minus 8. E is all you know, 1.6 into 10 to the power minus 19 whole square into R is 10 millimeter. 1 millimeter equals to 10 to the power minus 3 meter. So 10 millimeter equals to 10 to the power minus 2 meter whole square by 2m electronic charge. Let us take it as 9.1 equals to 10 into 10 to the power minus 31 kg. Hence, 9 into 2.56 into 10 to the power minus 38 minus 46 minus 50 divided by 2 into 9.1 into 10 to the power minus 31. If we take it as 9, then the calculation will be simpler and it will be nearly 1.3 into 10 to the power minus 19. 1.3 into 10 to the power minus 19 joule. Now minus 19 joule. But all the options are given in electron volt unit. So you have to convert this energy into electron volt. 1.3 into 10 to the power minus 19 divided by 1.6 into 10 to the power minus 19 EV. So joule unit is converted to electron volt, 0.8 into 0.8 electron volt. So the energy of the electron that was revolving in the circular track is 0.8 electron volt. Now let us see the energy of the hydrogen atom electron emitted from the hydrogen atom. So let us see the energy radiated from the hydrogen atom. Energy of the second Bohr orbit, all you know, is minus 3.4 electron volt, and that of the third Bohr orbit is minus 1.51 electron volt. So the energy difference is 1.9 electron volt approximately. This sort of energy falls on the photoelectric material or photoelectric cell, and a portion of this energy has triggered electron to have kinetic energy 0.8 electron volt. So the work function is the rest amount, that is the difference in between 1.9 electron volt and 0.8 electron volt, that is 1.1 electron volt. So the answer to the question number 2 is B. So 2B is our correct answer. Next, let us go to the third problem. What does it say? We see that it is a simple logic gate circuit, and the logic gate circuit equivalent logic gate circuit equivalent circuit চাওয়া হয়েছে. It is we have to find the equivalent logic gate circuit. From the first NOT gate we get the output as A inverse. From the second NOT gate it is B inverse, and there is a NAND gate. From the NAND gate we find A inverse into B inverse whole inverse, that is equals to A plus B. So the ultimate gate is OR gate, which gives the Boolean addition. So the answer to the question number 3 is C. Let us see the fourth question. The figure represents voltage regulator circuit using a Zener diode. The breakdown voltage of the Zener diode is 6 volt. So the Zener diode breakdown voltage is 6 volt. And the load resistance is 4 kilo ohm. RL equals to 4 kilo ohm. The series resistance in the circuit RI is 1 kilo ohm. If the battery voltage VB If the battery voltage varies from 8 volt to 16 volt, 8 volt to 16 volt battery voltage varies. What are the minimum and maximum values of current through the Zener diode? Then we have to calculate the minimum and maximum values of current through the Zener diode. First of all, the voltage drop against the Zener diode is 6 volt, so the voltage drop against the load resistance RL is also 6 volt. So the current through the resistance RL is V by RL, that is 6 by 4, that is 1.5 milliampere. So the current through this juncture is 1.5 milliampere. When the source voltage is 8 volt, then the current, then the voltage drop against RI is 2 volt. So the current II, that is through RI, is 2 by 1, that is 2 milliampere. Of the 2 milliampere, 1.5 milliampere is going through the load resistance. Hence the Zener current in this case is 0.5 milliampere for the first case. For the second case, total voltage varies from what? 8 to 16 volt. So total voltage is 16 volt. Voltage drop against the Zener diode is 6 volt. So the voltage drop against RI is 10 volt. So the current II against RI is 10 by 1, that is 10 milliampere. Of the 10 milliampere current through the load resistance is 1.5 milliampere. So the rest amount of current going through the Zener diode, and it is 8.5 milliampere. So in the first case, current through the Zener diode was 0.5 milliampere. In the second case, it was 8.5 milliampere. So we find that in the first case, current through the Zener diode is 0.5 milliampere. In the second case, that is the maximum current through the Zener diode is 8.5 milliampere. So the correct answer is 4C. Let us see the next question, that is the question number 5. What does it say? For photoelectric effect with incident photon wavelength lambda, the stopping potential is V0. Identify the correct variations of V0 lambda and 1 by lambda. So for wavelength lambda, we know that photoelectric equation gives Hc by lambda equals to EV0 plus phi 0, where phi 0 is the work function and V0 corresponding to stopping potential. Now, we are to find the nature of the curve in the two cases, V0 versus lambda and V0 versus 1 by lambda. Let us take the case 1 by lambda at first. Let 1 by lambda equals to x or y. X, let it be x. Then Hc by lambda is Hcx equals to EV0 plus phi 0. It is obvious that x is in linear power, V0 also in linear power, so the nature of the line should be straight line. Now, EV0 equals to Hcx minus phi 0. So V0 equals to Hc by E into Ax minus phi 0. So in this case, we will get a straight line with positive slope. So V0 1 by lambda, V0 versus 1 by lambda curve should be straight line with positive slope, and among the curves there is only one straight line with positive slope, that is C. So C is one of the correct option here. Next, let us see what is the variation or how the variation of V0 lambda. From the equation 1, if we take an approximation, let lambda is small. When lambda is small, Hc by lambda large, and for larger values of Hc by lambda, EV0 should be large. And when EV0 is larger enough than phi 0, we may neglect phi 0 with respect to EV0. In that case, Hc by lambda equals to EV0. So V0 into lambda equals to Hc by E equals to constant. So V0 into lambda equals to constant. So the nature of the curve is almost rectangular hyperbola. And there is only one curve which is of that nature, that is A. So our correct option is A and C. And in the multiple choice type option, there are two correct answers, and we find that A and C is in option number B. So the correct alternative choice of the question number 5 is B. Next, let us see the question number 6. It is a question from radioactivity. Two radioactive substances A and B having decay constant 5 lambda and lambda respectively at t equals to 0, sample has the same number of the two nuclei. Let it be N0. Let it be N0. The time taken for the ratio of the number of the nuclei to become 1 by E square. Now, for the first case, the number being N1. So, N1 equals to N0 e to the power minus 5 lambda t, as decay constant is 5 lambda in this case. For the second case, let it be N2, number of nuclei present equals to N0 into e to the power minus lambda t. So dividing equation 1 by equation 2, we get N1 by N2 equals to e to the power minus 5 lambda t by minus e to the power minus lambda t, that is e to the power minus 4 lambda t. Now, by the given condition, then time taken for the ratio of the number of the nuclei to become 1 by E square. So, N1 by N2 equals to 1 by E square, that is e to the power minus 2. So, comparing both sides of the equation 3, we get minus 2 equals to minus 4 lambda t. So, t equals to 1 by 2 lambda. So, our correct answer is B. So, the correct answer of the question number 6 is B. Let us see the next question, that is our question number 7. In the question number 7, we see a particle of mass m moves in a circular orbit in a central potential UR equals to half k r square. If both quantization conditions are applied, radii of possible orbitals and energy levels vary with quantum number as, or Rn, we are to find the relation between Rn and n, and also En and n. So, first of all, potential function UR is given equals to half k r square. We know that intensity is equals to du or del u del r equals to half k into 2r, that is your kr. That is your kr. Now, Bohr quantum condition gives mvr equals to nh by 2 pi. And DODR is the force, that is mv square by r equals to kr. So, mv square by r equals to kr. So, v square is proportional to r square, v is proportional to r. So, from equation number 1, we find that if we put v is proportional to r, then r square is proportional to n, so r is proportional to root n. So, we get one solution there, Rn is proportional to root n. Now, energy. Energy, the kinetic energy of the electron is half mv square. And also potential energy is half k r square. mv square by r equals to kr. So, half mv square equals to kr square by 2. mv square equals to kr square. So, half mv square equals to kr square by 2. So, the total energy, kinetic energy half mv square equals to kr square by 2, and potential energy is also kr square by 2. So, the total energy is kr square. And r is proportional to root n. So, total energy En is proportional to r square is proportional to n. So, En is proportional to n and r is proportional to root n. We find this option in the option number C. So, The answer, correct option of the question number 7 is C. Next, we see the question number 8. In this question, an electric field of light wave is given by E equals to 10 to the minus 3 cos 2 pi x by 5 into 10 to the minus 7 minus 2 pi into 6 into 10 to the 14 t x Newton per coulomb. This light falls on a metal plate of work function 2 electron volt. The stopping potential for photoelectrons. Here electric field of light wave is given. All you know that light wave is electromagnetic wave, and that wave equation of the electric vector is given. We know that E equals to E0 cos 2 pi x by lambda minus omega t. This is the given form. So comparing this, we get lambda equals to 5 into 10 to the power minus 7 meter. That is your 5000 angstrom. 5 into 10 to the power minus 7 meter, that is your 5000 angstrom, because this is equals to 5000 into 10 to the power minus 10 meter. 10 to the power minus 10 meter equals to 1 angstrom. So this lambda is 5000 angstrom. So the corresponding energy of the photon En equals to 12.42 by 5, because it is 5000 angstrom. We have to put only 5 here. That is equals to 2.24448 nearly. So the total energy of the incident photon is 2.48 electron volt. Energy is given in electron volt unit. Now the work function is 2 electron volt. Now phi 0 is 2 electron volt. So the rest amount is the kinetic energy, maximum kinetic energy of the electron is the difference between the two, that is 0.48 electron volt. So the stopping potential V0 is 0.48 volt. So the correct option is A. So the correct option to the question number 8 is A. Let us switch over to the next problem. It is another interesting problem here. Using a nuclear counter, the count rate of emitted particles from a radioactive source is measured. At t equals to 0, it was 1600 counts per second, and at t equals to 8 seconds, it was 100 counts per second. So, dN2 dt by dN1 dt, that is the rate of activity ratio, that is equals to is proportional to N2 by N1. So N2 by N1 ratio is proportional to dN2 by dt by dN1 by dt. dN2 dt becomes 100, whereas dN1 dt was 1600. So the ratio is 1 by 16. So half to the power 4, 1 by 16 equals to half to the power 4. So within this span of 8 seconds, we come across 4 half-lives, that is 4 into t half equals to 8 seconds. So t half equals to 2 seconds. The count rate observed as count per second at t equals to 6 seconds, that is 6 seconds equals to 3 into t half. So then count rate is 1600 into half to the power 3, that is 200. So the count rate observed, counts per second at 6 seconds is 200. So 9B is our correct choice. Let us see the question number 10 now. It is a question from hydrogen atom problem. In a hydrogen-like atom, electrons make transitions from an energy level with quantum number n to another quantum number n minus 1. If n is greater than 1, the frequency of emitted radiation is proportional to all. We know the expression of wave number. Let us start from there. 1 by lambda equals to r into 1 by n1 square. Here n1 is n minus 1 whole square minus 1 by n2 square, that is n square. nu into lambda, frequency into wavelength equals to velocity of light. So 1 by lambda equals to nu by c. So 1 by lambda should be replaced by nu by c. So nu equals to Cr into what? N square into n minus 1 whole square, n square minus n minus 1 whole square. So that is equals to Cr into a square minus b square, a plus b, that is your 2n minus 1, and a minus b gives you 1 just, n square, where n is much greater than 1. So n minus 1 whole square nearly equals to n square. Let us put it here. And also 2n minus 1, as n is much greater than 1, 2n minus 1 is roughly equals to 2n. So gamma equals to Cr into 2n by n to the power 4. Approximate relation gives us this result, as n is much greater than 1. So gamma is nearly equals to Cr into 2 by n cube. We are to find the relation between frequency and the value of n, that is the quantum number of the orbit, and we find that gamma is proportional to 1 by n cube. So the right answer is D. So 10D is the correct answer. Next, let us see the next question. Here is a very easy question for us. Question number 11. Question number 11. A sample of radioactive material has mass m, decay constant lambda, and molecular weight capital M. Avogadro number is Na. The initial activity of the sample is, initial activity, we know that dN dt equals to lambda into n. So n is the number of non-disintegrated atoms or molecules, and atoms, let it be. Now we know that the relation of molecular weight and Avogadro number. In molecular weight, the number of atoms present is Avogadro number, or molecules present is Avogadro number Na. So for 1 unit mass, the number of atoms present Na by m. So in small m mass, number of atoms present Na into small m by capital M. So we should replace n by Na into small m by capital M. So lambda into Na into small m by capital M. So dN dt, the rate of disintegration, that is the activity, initial activity is lambda m Na by capital M. That is the option C is the correct one. So 11C is our choice. Now let us take the next question. That is a problem from radioactivity. A radioactive substance with decay constant 0.5 per second, that is your lambda equals to 0.5 per second, being produced at a constant rate of 50 nuclei per second. Being produced at a rate of 50 nuclei per second, if there are no nuclei present initially, the time after which 25 nuclei will present. Mind that from the decay theory we know that dN dt equals to minus lambda n. But here what is different here, a radioactive substance with decay constant 0.5 per second is being produced at a rate of 50 nuclei per second. So 50 nuclei are producing and disintegrating at as minus lambda n. So make the separation of variables, dN by 50 minus lambda n equals to dt. To find the relation between n and t, now make the integration, multiplying both sides by minus lambda. Now time varies from 0 to t. Let the number of atoms or molecules were 0 at first and ultimately it is n. So what we find that minus lambda dn by 50 minus lambda n. That is in the form dn by n. So the integration value will give us ln 50 minus lambda n, where limit varies from 0 to n equals to minus lambda into t. Now ln upper limit gives 50 minus lambda n, lower limit n equals to 0 gives ln 50. So 50 minus lambda n by 50 equals to minus lambda t. Now further calculation gives 50 minus lambda n by 50 equals to e to the power minus lambda t. Now lambda equals to half. Putting it there, lambda equals to half. So 50 minus n by 2 divided by 50 equals to e to the power minus t by 2. So 1 minus n by 100 equals to e to the power minus t by 2. Now n equals to 25, the time after which 25 nuclei will be present. So total number of nuclei present, n equals to 25. So put n equals to 25 there, it gives 1 minus 25 by 100 equals to e to the power minus t by 2. That is your 1/4, 1 minus 1/4, it is 3 by 4. Taking log ln 3 by 4 equals to minus t by 2. So t equals to 2 ln 4 by 3. To absorb the minus sign, we get it. So t equals to 2 ln 4 by 3. So our correct option is B. The correct option to the question number 12 is B. Now let us see the question number 13. What does it say? Question number 13. Consider the nuclear reaction. Here is also a nuclear reaction. X200 equals to A110 plus B90. If the binding energy per nucleon of X, A and B are 7.4 MeV, 8.2 MeV and 8.1 MeV respectively, then the energy released. So let us calculate the binding energy of each of the nucleon, each of the nucleus. For X, there are 200 nucleons and each having binding energy 7.4 MeV. So the total binding energy of X is 200 into 7.5. 1400 1480 MeV. Energy is 1480 MeV. Now total energy of A, binding energy of A, 110 into 8.2. 11 into 222, carry 2. 8 into 11, 88 plus 2, that is your 90. So 902 MeV. That of B equals to 90 into what? 8.1. 729 MeV. So the total energy of A and B is 1631 MeV. But that of X, reacting nucleus X, 1480 MeV. So the energy released is the difference between the two, that is your 151 MeV. So the energy released is 151 MeV. That is B is the correct option. So the correct answer of question number 13 is B. Next, question number 14. In this question, we see a gate circuit problem, logic circuit shown in the above, equivalent to which circuit? Let us see the original circuit at first. It is a OR gate. There are two inputs, one A and another B inverse. So output of the logic gate OR gate is A plus B inverse. Then it is fed to a NOT gate. So output of the NOT gate gives you A plus B inverse whole inverse. That is your A inverse into B. Morgan's theorem gives that is your A inverse B. Simply there is a product. So we may have some AND gate, and there is AND gate in the fourth option. So we will start from the AND gate option. There is A inverse B. So A with NOT gate gives you A inverse, and second one is B. So the output product is A inverse B. So D is our correct option. So question number 14 having correct answer D. Next, let us see the next problem, question number 15. Match list A1 with list 2. This is a matching type question. Let us see the correct matching. Source of microwave frequency to the list 1. Next, source of infrared frequency. Next, source of gamma rays. Next, source of X-rays. And to the right column, that is list 2, radioactive decay. From radioactive decay we get gamma rays here. So matching of C is 1. Source of microwave, it is from magnetron. So matching of A is 2. Source of infrared, actually infrared rays are emitted from atoms and molecules. So 4 is the correct answer. Next, source of gamma rays, we find it there. Source of X-rays, laser, RC circuit or inner cell electrons. That should be inner cell electrons. That is, we are talking about characteristics X-ray. So find the correct matching. A is 2. First, we find A is 2 in two options, C or D. Next, B. B is 4. So we see B is 4 in C, either C or D. C. C is 1, that is radioactive decay. C is 1, so D is our correct answer. So correct option to the question number 15 is D. Now let us see the question number 16. The wavelength of the photon by a hydrogen atom when an electron makes a transition from n equals to 2 to n equals to 1 state. All we know the wave number expression 1 by lambda equals to r into from 2 to 1 by 1 square minus 1 by 2 square. That is r into 1 minus 1/4. That is 3r by 4 equals to 1 by lambda. So lambda equals to 4 by 3 into 1 by r. 1 by r equals to 912 angstrom into 912. 304. That is 1216 angstrom. Means 121.6 nanometer. So correct option, that is 121.8, which is near to our answer. So A is the correct answer. So the correct answer of the question number 16 is A. Next, switch over to the next problem, that is problem number 17. What does it say? Let us see. Another interesting problem. The recoil speed of hydrogen atom after it emits a photon in going from n equals to 5 state to n equals to 1 state will be the recoil speed of hydrogen atom. Recoil speed of hydrogen atom when emits a photon. When it is emitting a photon, it will get recoil speed due to the back momentum. Energy carried by photon, all you know, that is h nu by c. that is the momentum carried by photon, where energy is h nu. So the momentum carried by photon is h nu by c, and all you know c equals to nu lambda. So nu by c equals to 1 by lambda. So this is h by lambda. This is the momentum carried by photon. So hydrogen atom will get the back momentum. Momentum carried by photon is h by lambda. So the atom will get recoil momentum. And due to recoil, momentum should be equals to h by lambda, and that is equals to mv. mv is the momentum of the hydrogen atom equals to h by lambda. We have to find the what we have to find? We have to find the recoil speed. So we have to find v. v equals to h by m lambda. h by m lambda. And again, lambda appears from the transition n equals to 5 to n equals to 1 state. So 1 by lambda equals to r into n equals to 5 to 1 state. 1 by 1 square minus 1 by 5 square. That is here. R into 1 minus 1 by 25. That is R into 24 by 25. So 1 by lambda equals to that. So lambda equals to 25 by 24 into R. All you know that 1 by R equals to 912 angstrom. 24 into 3, 8, 38. 38 into 25. 5 into 38, 119. 19, carry 19. 38 into 2, 76 plus 19, 950 angstrom. So lambda is 950 angstrom. Now H, 6.62 into 10 to the power minus 34. What is m of the hydrogen atom? That is your 1.67 into 10 to the power minus 27 kg. And lambda is 950 into 10 to the power minus 10 meter. So we get 1.6 into 6.67. This is nearly 3.9. So 3.9 by 950 into 10 to the power minus 37, 10 to the power 3. So 3900 by 950. 4, 318. 950. 4.1, nearly 4.1. And here is one option of that range, that is 4.17 meter per second. So correct answer of the question number 17 is A. Let us see the question number 18 now. In the question number 18, we see that a radioactive sample is undergoing alpha decay. At any time t, its activity is A, and then another time t2, the activity is A by 5. What is the average life of the sample? All you know that activity dN1 dt equals to A equals to N0 into e to the power minus lambda into T1. For the second case, dN2 dt equals to A by 5 equals to N0 e to the power minus lambda into T2. And we know that average life TA equals to 1 by lambda. Dividing equation 1 by equation 2, we get that 5 equals to e to the power minus lambda T1 by e to the power minus lambda T2. That is your e to the power lambda into T2 minus T1. Taking log of both sides of equation 3, we get ln 5 equals to lambda into T2 minus T1. So TA equals to 1 by lambda equals to T2 minus T1 by ln 5. So correct choice is T2 minus T1 by ln 5, that is your C. So the correct answer of question number 18 is C. Now let us see the next question, that is your question number 19. What does it say? A plane EM wave of frequency 500 MHz is traveling in vacuum along y direction. So C wave is propagating along y direction. A particular point in space and time B is 8.0 into 10 to the minus 8 into z Tesla. So the direction of B is along z direction. The value of electric field at the point is x, y, z are unit vectors. X cap, y cap, z cap are unit vectors along x, y, z directions respectively. All you know that E0 by B0 equals to C. B0 is given, so E0 equals to B0 into C. What is the value of B0 here? 8 into 10 to the power minus 8. And all you know, C equals to 3 into 10 to the power 8. That is 24 volt per meter. Value of E0 is. Now what about the direction? C equals to E cross B. Now C is along y direction. We do not know the direction of E. Direction of B is along z direction. So how can we get y? Y, z, x. So E is along x direction. But that, mind that y, how can we get y? X cross z, x cross z, E should be along x direction. Mind that if we go through the negative sense, because x cross z, we are going in the clockwise sense. So x should be with minus sign. So the vector should be of the value 24 volt per meter, but along minus x direction. So electric field at that point is minus 24x volt per meter. So the answer of the question number 19 is A. Now see the question number 20. Imagine that the electron in a hydrogen atom is replaced by a muon. The mass of muon particle is 207 times that of an electron and charge is equal to the charge of an electron. The ionization potential of the hydrogen atom will be. Ionization potential of the hydrogen atom is 13.6 electron volt. That is the energy to expel the electron from the innermost orbit to the outside the atom is 13.6 electron volt. Now we consider the case as energy of the first orbit equals to twice pi square m e to the power 4 by CH3. We see that En is proportional to m, where m is the mass of the electron. Now mass is 207 times that of the electron. So the now mass is 207 times. As En is proportional to m, so the energy of the first orbit and hence the ionization potential will be 207 times that of the normal hydrogen atom, which is 13.6. So the energy will be 207 into 13.6 electron volt. 207 into 6, 1242. 124. 207 into 3, 621 plus 124. 745. 5 carry 74. 27 plus 74. 207 plus 74. 281. 2815.2, that is B. So the correct answer to the question number 20 is B. Now let us see the question number 21. Here is another interesting problem from X-rays. What does it say? The intensity of X-rays from a Coolidge tube is plotted against wavelength as shown in figure. The minimum wavelength lambda c, and the wavelength of the K alpha line is lambda k. As the accelerating voltage is increased, what will happen in between the difference of lambda k and lambda c? Mind that lambda k is the characteristics line, and it depends upon the nature of the material used, target material of the X-ray used. As that, so far as target material is same, so lambda k is same. But what is lambda c? Lambda c, the minimum wavelength found in is lambda c. Actually, the electrons are accelerated to the target material, and the energy of the electron, accelerated electron, is actually converted into X-ray. And when the whole of the energy of the X-ray is converted, electron energy is converted to X-ray, then we get the minimum wavelength. From Dunhunt equation or Dunahunt equation, we may write down EV equals to HC by lambda minimum or lambda c. Then lambda c is proportional to 1 by v. So as v, that is the accelerating potential, is increasing, lambda c will decrease. So lambda c will go down. Hence the difference between lambda k and lambda c will increase. So lambda k minus lambda c will increase, because lambda k is the wavelength of the characteristics X-ray, which depends upon the target material. As the target material is the same, so there is no change in lambda k. But lambda c, according to Dunahunt equation, lambda c will decrease with the increase in the value of the accelerating potential. So the difference between lambda c and lambda k will increase. So A is the correct answer to the question number 21. So 21A is the correct answer. Now let us see the question number 22. It is a question from photoelectric effect, another interesting phenomena in physics. So let us take the next question, that is your question number 22. What does it say? The figure shows the variation of photoelectric current. The figure shows the variation of photoelectric current with anode potential for a photosensitive surface for three different radiations. Let IA, IB and IC be the intensities and FA, FB, FC be the frequencies for the curves A, B and C respectively. Then let us see. Now the frequency, as the material is same, variations of photoelectric current with anode potential for a photosensitive surface, material is same. Let us see, EV0 plus phi 0 equals to H nu. So when V0 is same, phi 0 is same, nu is same. So for the two cases, for A and B, the curves are meeting at a point A. It is a common point, and that is the stopping potential. As the stopping potential of A and B are equal, so FA equals to FB, frequency of radiation in this case, is equal. We also see that saturation current is same for B and C. So IB, intensity of radiation IB equals to IC. But IB or IC, that is greater than IA, as the current is proportional to the intensity of radiation incident on the metal. So FA equals to FB. So our correct choice is either A or C. But IA equals to IB, this is not right here. IA is less than IB or IC. So IA is less than IB. We find this all these two conditions correctly in question number C. So answer of the question number 22 is C. Next question, 23. This question is also from photoelectric effect. Let us see the problem. Radiations of wavelength lambda is incident on a photocell. The fastest emitted electron has a speed v. If the wavelength is changed to 3 lambda by 4, the speed of the fastest emitted electron. As the wavelength is changed from lambda to 3 lambda by 4. All you know, the energy carried by photon is E equals to hc by lambda. When lambda is 3 by 4 times, then energy is 4 by 3 times incident energy. But work function is always same. So when incident energy is 4/3 times, kinetic energy of the electron will be greater than 4/3 times. So half mv2 square should be greater than the 4/3 times than of the kinetic energy of the first case, half mv1 square. So v2 is greater than root over 4 by 3 into v1. So v2 is greater than root over 4 by 3 into v1. It is clear from the fact, as the wavelength is decreasing up to 3/4 of the initial one, hence the energy of the incident photon is increasing 4 by 3 times. So far as phi 0, that is the work function, is unchanged, so the portion shared as a kinetic energy will be more than 4/3 times the incident energy of the first case. So kinetic energy of the electron now, emitted electron, maximum kinetic energy of the emitted electron now is greater than the 4/3 times that of the previous one, that is half mv1 square. So if we make some mathematical calculation, we find that easily that v2 is greater than root over 4 by 3 into v1, or v1 into 4 by 3 to the power half. Here v1 is given as v, so it should be v into root over 4 by 3. v2 is greater than, so v dash is greater than root over 4 by 3. This is the correct option. So the answer to the question number 23 is A. Now see the question number 24. Here, some energy levels of a molecule is shown in the adjacent figure. The wavelength R, lambda 1 by lambda 2 is given by. Here is two radiations. First one lambda, corresponding to two orbits, minus 2e and e. So the energy difference between the orbits is E equals to hc by lambda 1. Now, lambda 2, we get lambda 2 for the transition in between the orbits having energy minus e and minus 4e by 3. So the energy difference is e by 3. So we find that e by 3 equals to hc by lambda 2. 1, 2. Now lambda 2 is in the denominator. So divide 2 by 1 we get, 1/3 equals to lambda 1 by lambda 2. So the correct answer is C. So 24 for the question number 24, C is the correct answer. Now see the next question, question number 25. Question number 25. There is a question from logic circuit. The output of the given logic circuit is, we have to find the output of the circuit. Now, we see that there is a AND gate with here is a NAND gate, here is a NAND gate, number 2 it is also a NAND gate, and there is a OR gate, and ultimately there is a NAND gate. First one, for the NAND gate 1, this is NAND gate 1, we see that input A and B, so the output is AB inverse, that is equals to A inverse plus B inverse from Morgan's theorem. So for the second NAND gate, we get one of the input is A, second one is A inverse plus B inverse. So we get the output as A into A inverse plus B inverse whole inverse. Now A into A inverse equals to 0. So we get A inverse, A into B inverse of the whole inverse, that is A inverse into B. So here we get A inverse B from this calculation. A inverse, AB inverse whole inverse equals to A inverse plus B inverse of inverse, that is B. A inverse plus B from here. From here we get A inverse plus B. From the OR gate, what we find that there are two portions. One of the input is A inverse plus B inverse and another is B. So OR gate will add them, A inverse plus B inverse plus B equals to A inverse plus 1. Why? Because we know that B plus B inverse equals to 1. Either if B is 0, then B inverse is 1. If B is 1, then B inverse is 0. But the addition will give you 1. Now, ultimately, we find one of the NAND gate having two inputs as A inverse plus B and A inverse plus 1. So, Y should be A inverse plus B into A inverse plus 1 whole inverse. All you know that A inverse into A inverse square equals to A inverse plus B into A inverse plus A inverse plus B. Now A inverse plus A inverse, you may write 1 A inverse plus B A inverse plus B. Take B as common, A inverse plus 1. Now this is A inverse plus 1 equals to 1. So B into A inverse plus 1 means B. So we get from Morgan's theorem, this is equals to A inverse of inverse into B inverse, that is A into B inverse. So the answer is A. So the correct answer to the question number 25 is A. Now see the question number 26. There is a question with diodes. The circuit shown in the adjacent figure contains two diodes. Each has a forward resistance 50 ohm. If the EMF of the battery is 6 volt, the current through the 100 ohm resistor. We find that D1 diode is in forward bias, so it will conduct. But D2 diode is in reverse bias. It must not conduct. So we may actually neglect the portion 2, the middle portion of the circuit totally in the equivalent circuit. So forward bias resistance of the diode is 50 ohm. So the net resistance of the circuit is 50 plus 150 ohm plus 100 ohm. So net resistance of the circuit is 300 ohm. Hence the current I equals to EMF of the battery 6 volt by 300 ohm equals to 0.02 ampere. So in ampere unit, current should be 0.02 ampere and it will flow through the 100 ohm resistance. So our answer for the current through the 100 ohm resistor is 0.02 ampere. So the correct answer of the question number 26 is B. Now let us switch over to the question number 27. What does it say? The question number 27 is a question from nuclear physics, basic question from nuclear physics. A star initially has 10 to the power 40 deuterons. It produces energy via the process 1H1 plus 1H2 plus 1H2 equals to 1H3 plus P. So first of all, we write down the equation 1H2 plus 1H2 equals to what? 1H3 tritium plus P. In the next reaction, we see that 1H2 plus 1H3, 1H2 plus 1H3 equals to what? 2He4 plus neutron. 2He4 plus neutron. The average power radiated by the star is 10 to the power 16 watt. The deuteron supply of the star is exhausted in a time of the order of. So when the reaction will stop, that is our point of consideration. Now add the two equations. And from the right hand side and left hand side, 1H3 will cancel out. So we will get 3 into H12. It will yield 2He4 plus proton plus neutron. Now mass of each is given. Mass of H2 is 2.014. There are 3 1H2. So total mass of the left hand side is 6.042. And for the right hand side, for the helium 2He4, it is 4.001. For proton, it is given 1.007. For neutron, it is given 1.008. So we add them all. 6.016. So the mass difference in between the delta M equals to 0.026 AMU. Now, 3 of the deuterons is reacting in each reaction, each complete reaction. So, there are 10 to the power 40 number of deuterons initially. So, total number of possible reaction is 10 to the power 40 by 3, and each reaction we get 0.026 AMU of energy, that is into 931 MeV or 930 approximately. For making calculation easy, we are taking 930 instead of 931. So this is the energy liberated. And how much energy power is radiated? 10 to the power 16 watt, that is 10 to the power 16 joule per second. Now we have calculated this energy in MeV. So when we are converting it into joule, it should be multiplied by 1.6 into 10 to the power minus 13. And how many seconds? 10 to the power 16 joule per second energy is radiated. So let it be 40 seconds. So we have to calculate T. What is the value of T now? T equals to, now 310. Let 310 into 0.026 into 10 to the power 40 into 1.6 into 10 to the power minus 13 by 10 to the power 16. Let it be 10 to the power minus 29, 10 to the power 40, 10 to the power 11, 310 into 16 into 26, 310 into 1.6, 16 into 116, carry 1, 3 into 16, 48, 49, 496 into 0.026, that is equals to 496 into 0.026, what 490.6 into 0.26 into 10 to the power 11, that is 1/4 of 50, nearly 12.5 into 10 to the power 11, that is your 1.25 into 10 to the power 12. So this should be of the order of 10 to the power 12 second. So answer should be 10 to the power 12. So correct answer to the question number 27 is C. Now see the question number 28. A nucleus at rest breaks up into two nuclear parts. Have their velocities ratio 2:1. What will be the ratio of their radii of the nuclei? Now their velocity ratio is given. Nucleus is breaks up into two parts. And for this breakup, momentum conservation law must be valid. So the momentum of each part, that is m1 v1 equals to m2 v2. Their magnitude should be equal, but they are in opposite direction. Neglecting the sign of momentum, we may just equate the momentum m1 v1 equals to m2 v2. Now having velocities in the ratio 2:1, so v1 is 2v, so m1 into 2v equals to m2 into v. So we find that m1 by m2 equals to half. Ever let the nuclei are spherical in shape, then m1 equals to what? m1 equals to 4/3 pi r1 cube, কারণ we are to express it in terms of radii. So when taking the nucleus in a spherical shape, we may write down m1 equals to 4/3 pi r1 cube into rho. For the second case, it may be write down as 4/3 pi r2 cube into rho. 4/3 pi being cancelled out, rho cancel out, equals to half. So R1 by R2 equals to 1 by 2 to the power 1/3. 1 by 2 to the power 1/3. We find this in option C. So answer of the question number 28C. Now see the last page, 29. Question number 29, last page. Light is incident normally on a completely absorbing surface with an energy flux of 25 watt per meter square. 25 watt per meter square. If the surface has an area 25 centimeter square, the momentum transferred to the surface in 40 minutes time duration. Momentum transferred, change in momentum, equals to impulse of a force F into delta T. Now let us see what is the force acting. Now the momentum given to the surface by radiation P equals to I by C. Hence the force F equals to what? Force, this is the momentum, actually P equals to, that is the pressure exerted on the surface is I by C. So the pressure exerted is I by C. So F equals to P into A equals to IA by C. The radiation giving some pressure when it is leaving the surface, and such pressure is I by C, where I is the intensity of radiation and C is the velocity of light in vacuum. Now the force acting on the surface is P into A equals to IA by C. Now if delta T be the time taken by the radiation to leave the surface, then the momentum, change in momentum, delta P equals to what? F into delta T equals to what? IA by C into delta T. Now what is I? I is 25 watt per centimeter square. That is 25 watt per centimeter square. 1 centimeter square means 10 to the power minus 4 meter square. So this should be 25 into 10 to the power 4 watt per meter square. A, what is the surface area here? 25 centimeter square. That is equals to 25 into 10 to the power minus 4 meter square. Now C is 3 into 10 to the power 8. And what is delta T? Delta T is 40 minutes. That is 40 into 60 seconds. 10 to the plus 4 and minus 4 cancel out. 3 into 20. 25 into 25. 40 into 25 means 1000. 25 into 20 means 500 by your 10 to the power 8. That is your 5 into 10 to the power 5. By 10 to the power 8, that is your 5 into 10 to the power minus 3. We find this value in the option D. So the correct answer to the question number 29 is D. So the force exerted on the surface equals to pressure into area, and pressure exerted on the surface by radiation when it is leaving the surface is I by C, where I is the intensity of radiation. Now, here is the last question. A photoelectric material having work function phi0 is illuminated with light of wavelength lambda. The fastest photoelectron has a de Broglie wavelength lambda d. The change in wavelength of the incident light by wavelength delta lambda results in change delta lambda d by lambda d. Then the ratio of delta lambda d by delta lambda. Let us see first equation. What we are just having a light of wavelength lambda incident on the surface. So the energy of the photon carried hc by lambda equals to what? Phi0 plus energy, kinetic energy, but we have to express it in terms of momentum because we are to switch over to the Broglie wavelength. Lambda d equals to, we know that in lambda d of the Broglie wavelength equals to lambda equals to h by p. Now hc by lambda equals to phi0 plus Emax. Emax may be given in terms of p, so phi0 plus p square by 2m. Now differentiating equation 1 and also equation 2, what does we get? First of all, From equation 1, if we differentiate it, we get hc minus hc by lambda square into d lambda সমান equals to 1 by 2 m into twice p into dp. And from the second equation, we get d lambda d equals to minus h by p square into dp. So replacing these values, we get minus hc by lambda square into d lambda equals to hc by lambda d lambda equals to replace p square dp by p square. So dp in terms of p, and from making calculation here, dp in terms of p, we may write down p by m dp equals to p square by h into d of d lambda. Now put the values of p, we may come to the conclusion that delta of lambda d by delta lambda is proportional to lambda d cube by lambda square. So lambda d cube by lambda square is our correct answer, which is found in D. So from the first equation, we may write down that minus hc by lambda square equals to p by m into dp. From the second equation, we find that d lambda d equals to minus h by p square into dp, and p equals to h by lambda d. So we have to find delta lambda d by delta lambda. So delta lambda d by delta lambda, hc by lambda square into delta lambda, it was there. Now replace dp. If we replace dp, then we find that minus hc by lambda square into delta lambda equals to p by m. dp means d lambda d. dp means d lambda d into p square by h. So delta lambda d, what we require? We require delta lambda d by delta lambda. So delta of lambda d by delta lambda equals to 1 by lambda square into p cube. This is proportional, but p is equals to h by lambda d. So proportional to, if we put the value of p here for the de Broglie wavelength, h by lambda d. So p cube equals to h cube by lambda d cube. This is proportional to lambda d cube by lambda square. So our option D is correct. So the answer to the question number 30 is D. That is the end of our discussion, analytical discussion of the chapter. Now let us see the MCQ solution at a glance. Answer of the question number 1 is A, 2B, 3C, 4C, 5B, 6B, 7C, 8A, 9B, 10D, 11C, 12D, 13B, 14D, 15D, 16A, 17A, 18C, 19A, 20B, 21C, 22C, 23A, 24C, 25A, 26B, 27C, 28C, 29D and 30D. Topic of the next mock test 3, that is the mock test 3, is thermodynamics, kinetic theory, transmission of heat, SHM, simple harmonic motion. These are 4 new topics, yes, and also modern physics as a revision topic. Date of examination, most probable date of examination is 27th May 2022. Probable number of questions should be 45 and 30 from the new topics, that is your thermodynamics, kinetic theory, transmission of heat and SHM, and 15 from revision of lesson, that is from modern physics. And the exam is scheduled to be held on 27th May. I suggest you to prepare yourself for the exam, and that's all. Good night.